What's up guys, this is Massey. Welcome to another video. In this video I want to talk about vector projections. So whenever we project a vector over another vector, we need to use this formula. We have projection of V on U. The projection of V on U, if you want to calculate it, is going to be the magnitude of vector V times cosine theta. And the theta is the angle between vector V and vector U. We can also find it using this formula as well. The dot product of U and V divided by the dot product of U and U multiplied by U. If theta is between 0 and 90, the projection of the magnitude of projection of V over U is going to be the magnitude of vector V times cosine theta, or it's going to be the dot product of U and V divided by magnitude of U. And if theta is between 90 and 180 degrees, it's going to be negative magnitude of V times cosine theta. And it's going to be equal to negative the dot product of U and V divided by magnitude of U. In other words, we can say projection of V over U equals to the magnitude of V times cosine theta. That gives you the magnitude of this projection. And the direction is coming from U divided by the magnitude of U. Let's see some examples. Here we have two vectors and we want to find out the projection of V over U. We can say we have projection of V and U. You can say that's going to be 1 times cosine 50, which will be cosine 50, and that's going to be equal to 0.64. Next one is the projection of P over Q. So projection of P over Q is going to be magnitude of P times cosine theta. So it's going to be negative. So we have 20 times cosine 120. That will be 20 times cosine 120. That will be negative 10. And since we want to find out the magnitude of it using this formula, because the theta is between 90 and 180, we need to multiply it by another negative. So that will be negative times negative is going to be positive 10. Now we want to find out the projection of D on C. So it's going to be projection of vector D over C. Based on the formula, we can say that's going to be equal to the dot product of D and C divided by dot product of C and C times vector C. So that will be 2 times 1 plus negative 3 times 4 divided by the dot product of C and C. It's going to be 1 times 1 plus 4 times 4 times the vector C, which is 1 and 4. That will be 2 minus 12 divided by 1 plus 16. That will be negative 10 over 70 times 1 and 4. And when you multiply, it's going to be negative 10 over 17, negative 40 over 70. That's going to be the vector of the projection. Next one, determine the projection of U and V. This be the projection of U on V. So that will be, based on the formula, is going to be equal to magnitude of U times cosine theta. And it's going to be positive because that's less than 90. So we have 10 times cosine 25. So 10 times cosine 25, that will be 9.06. Next one, we have magnitude of 7, magnitude of V is 9, and the angle in between is 110. So since it's greater than 90, it's going to be negative u times cosine theta. Magnitude of u is 7 cosine 110, so it's going to be negative 7 times cosine 110. That will be 2.4. Next one, the projection of u on v is going to be u dot cosine theta. It's going to be 20 times cosine 90. That will be 0. Next one, determine the projection of the first vector on the second. So that will be projection of A over B will be the dot product of A and B divided by the dot product of B and B times B. So the dot product of A and B is going to be 6 times 11 plus negative 1 times 5 divided by 11 times 11 plus 5 times 5. Multiplied by vector B, which is 11 and 5. So it's going to be 66 minus 5 divided by 121 plus 25 times 11 and 5. So 66 minus 5 divided by 146. So we have 61 over 146 times 11. 61 times 11 is going to be 671 over 146, and 5 times 61 is 305 over 146. Now determine the projection of C over D. It's going to be projection of vector C over vector D. It's going to be the dot product of C and D over the dot product of D and D multiplied by vector D. So it's going to be 2 times negative 4 plus 7 times 3 divided by D and D, negative 4 times negative 4 plus 3 and 3 times D, which is negative 4 and 3. That will be negative 8 plus 21, 16 plus 9, negative 4 and 3. So 21 minus 8, that will be 13 over 25, negative 4 and 3. So we have 13 here. It's going to be negative 52 over 25. And then we have 39 over 25. That's going to be the vector of the projection. Now in this example, we want to find out the projection of E on F. So it's going to be the dot product of E and F over the dot product of F and F multiplied by F. So the dot product of E and F is negative 2 times negative 5 plus negative 5 times 1 divided by the dot product of F and F is going to be negative 5 times negative 5 plus 1 times 1 dot F, which is negative 5 and 1. Negative 2 times negative 5 is 10 minus 5 divided by 25 plus 1 is 26, negative 5 and 1. So we have 5 over 26, negative 5 and 1. So that will be negative 25 over 26 and 5 over 26. Vectors G and H. G is 10 and negative 3, H is 4 and negative 4. Projection of G over H will be dot product of G and H divided by dot product of H and H times H. So that will be 10 times 4, 40, plus negative 3 times negative 4 divided by the dot product of H and H, 4 times 4, plus negative 4 times negative 4. Dot H, which is 4 and negative 4. That will be 40 plus 12 is 52 divided by 16 plus 16, 32. So that will be 52 times 4, 32, negative 52, 4 times 4 divided by 32. So when you simplify it, when you reduce it, it's going to be 13 over 2 and negative 13 over 2. Now in this example, it says, show the projection of V on U, which is the magnitude of V times cosine theta times U divided by magnitude of U, can be written as projection of V on U, which is going to be equal to the dot product of U and V divided by dot product of U and U times U. So we can say the dot product of U and V divided by the dot product of U and U times U. Here, the dot product is going to be the magnitude of U times magnitude of V times cosine theta divided by magnitude of U times magnitude of U times cosine 0, which is going to be 1, so I don't write anything. So then U and U cancel out, and then I can take V cosine theta out, and here we have U over magnitude of U, which is what we have in here. Next one, it says for the vector A, negative 3, 4, and 5 root 3, B is negative 2, 2, and negative 1. Calculate each of the following scalar projection. A on B, which is going to be projection of A on B, will be A dot B over B dot B times vector B. So A dot B is negative 3 times negative 2 plus 4 times 2 plus 5 root 3 times negative 1 divided by the dot product of B and B is going to be negative 2 times negative 2 plus 2 times 2 plus negative 1 times negative 1 dot this vector, which is negative 2, 2, and negative 1. So that will be 6 plus 8 minus 5 root 3 divided by 4 plus 4 plus 1 dot negative 2, 2, and negative 1. So that will be 14 minus 5 root 3 over 9 times negative 2, 2, and negative 1. When you multiply it, it's going to be 10 root 3 minus 28 over 9. Then we have 28 minus 10 root 3 over 9. And then 5 root 3 minus 14 over 9. That's the final answer, the vector for the projection. Now here it says, find out the projection of B on A. So I'm going to use the same numbers. Here we have A and B here. Projection of B on A is going to be dot product of B and A divided by dot product of A and A times A. I have the dot product of A and B, which is going to be here 14 minus 5 root 3. The magnitude of A is, or A dot A is going to be negative 3 times negative 3 plus 4 times 4 plus 5 root 3 times 5 root 3 times negative 3, 4, and 5 root 3. So we have 14 minus 5 root 3, 9 plus 16 plus 25 times 3, which is 75. And when you multiply it, it's going to be negative 3 times 14 minus 5 root 3 over 100. 4 times 14 minus 5 root 3 over 100. and 5 root 3 times 14 minus 5 root 3 over 100. So that's gonna be the final answer to this question. So we can say that for the review, calculating scalar projection, the scalar projection of A on B is the dot product of A and B divided by the magnitude of B, and the scalar projection of B on A is the dot product of A and B divided by magnitude of A. So in general, these two are going to be different because the magnitude of A and B is different. Now the direction cosine for OP, which is A, B, and C, are cosine alpha is A over square root of A squared plus B squared plus C squared. Cosine beta is B over square root of A squared plus B squared plus C squared. Cosine gamma is C over square root of A squared plus B squared plus C squared, where alpha, beta, and gamma are the direction angle between the position vector OP and the positive x-axis, y-axis, and z-axis respectively. So these are going to be the angles between OP and x-axis, y-axis, and z-axis. Now let's see this example. It says determine the angle that the vector OP 2, 1, and 4 makes with each of the coordinate axes. So I can say cosine alpha, which makes it with the x-axis, equals to A over square root of A squared plus B squared plus C squared, as what we have. So A is 2. Here we have square root of 2 squared plus 1 squared plus 4 squared. So that will be 2 over square root of 4 plus 1 plus 16. We have 2 over square root of 21. Cosine beta is 1 over square root of 4 plus 1 plus 16, which is going to be 1 over square root of 21. And finally, cosine gamma is going to be 4 over square root of 21. So alpha is cosine inverse 2 over root 21. Beta is cosine inverse of 1 over root 21. And gamma is cosine inverse of 4 over root 21. So 2 divided by the square root of 21 is going to be cosine inverse of 0.436. Here we have cosine inverse of 1 divided by square root of 21, which is 0.218. And here we have cosine inverse of 4 divided by square root of 21. That will be 0.873. Cosine inverse of 0.436 is going to be 64 degrees. Cosine inverse of 0.218 is 77 degrees. Cosine inverse of 0.873 is 29 degrees. Now in this example, it says for the vector OP, which has this component negative 2 root 2, 4, and negative 5, determine their direction, cosine, and the corresponding angle that this vector makes with the positive z-axis. So we're going to say cosine gamma equals to negative 5, the last one, over square root of negative 2 root 2 to the power of 2 plus 4 squared plus negative 5 squared. That will be negative 5 over 2 root 2. It's going to be 8 plus 16 plus 25, which is going to be 49. So negative 5 over square root of 49, which will be negative 5 over 7. So negative 5 over 7 is negative 0.714. So gamma is cosine inverse of negative 0.714. Which is going to be 135 degrees, or 135.6 degrees to be exact. Next example, for the vector P 3, 6, and negative 2, and q, negative 4, 5, and negative 20. Determine the scalar and vector projection of P on Q. So we have projection of P over Q. So if we do the scalar, it's going to be P dot Q over magnitude of Q. So that will be 3 times negative 4 plus 6 times 5 plus negative 20 times negative 22. 22, 20, yeah. And here, square root of Q, negative 4 squared plus 5 squared plus negative 20 squared. That's going to be negative 12 plus 30 plus 440. It's going to be 16 plus 25 plus 400. So we have 440 plus 30 minus 12. That will be 458 divided by 16 plus 25 plus 400. That will be 441, which is going to be 21. And here we have 480, 458 divided by 21. That will be 21.81. That's the scalar vector projection. Scalar projection. Now find out the vector projection, which is projection of P, Q. It's going to be P dot Q times Q dot Q times Q. So the dot product of P and Q, we already found it. That's 458. The dot product of Q and Q is going to be magnitude of Q squared. Magnitude of Q squared is going to be just 441, which is square root of 441 times square root of 441, which is going to be just 441, times vector Q, which is negative 4, 5, and negative 20. So we can say that will be that's going to be negative 4.15, 5.19, negative 20.77. That's the vector projection. Now in this example, it says for each of the following, determine the scalar and vector projection. So projection of x on y and vector projection in here. That's the scalar and vector. So it's going to be x dot y divided by magnitude of y, and here we have the dot product of x and y divided by dot product of y and y times y. So the dot product of x and y is 1 times 1 plus 1 times negative 1 divided by magnitude of this one is going to be 1 squared plus negative 1 squared. That will be 1 minus 1. Here we have 1 plus 1. There's 0 divided by root 2 is going to be 0. Next one, the dot product of is 0 divided by this one is 2 dot y, which is 1 and negative 1. When you multiply it, that's going to be 0 and 0. Next one, it will be the dot product of x and y divided by magnitude of y. It's going to be 2 times 1 plus 0 times 2 root 3 divided by square root of 1 squared plus 0 squared. That will be 2 plus 0 divided by 1, which is going to be 2. Next is going to be the dot product of x and y divided by root y to the power of 2 times y, which is going to be 2 over 1 times y, which is 1 and 0. That will be 2 and 0. Next one. For the scalar, we have the dot product of x and y divided by magnitude of y. That will be 2 times negative 5 plus 5 times 12 divided by magnitude of y, which is negative 5 squared plus 12 squared. That will be negative 10 plus 60 over 25 plus 144, 50 over 169. That will be 50 over 13. If you want to find out the vector projection, the dot product of x and y divided by the dot product of y and y times the vector y. So it's going to be 50 over 13 times 13 dot negative 5 and 12. So that will be negative 250 over 169 and 600 over 169. That's the vector projection. In this example, it says determine the scalar and vector projection of a, negative 1, 2, and 4 on each of the three axes. We had it before. It's going to be cosine alpha equals to negative 1 over square root of negative 1 squared plus 2 squared plus 4 squared. That will be negative 1 over 1 plus 4 plus 16, negative 1 over square root of 21. So alpha is going to be cosine inverse of negative 1 over 21. Which is going to be 102 degrees. Next one is cosine beta equals to 2 over square root of 21. So beta is cosine inverse of 2 over root 21. (64 degrees). Cosine gamma 4 over square root of 21. So gamma is cosine inverse 4 over square root of 21. Now 4 divided by square root of 21. Cosine inverse 0.8728. That will be 29 degrees. Then it says determine the scalar and vector projection of m, negative 1, 2, 4 on each of the three axes. So that will be negative 1, 2, and 4. Let's say on x-axis we have 1, 0, and 0, which is going to be negative 1, 2, and 4 dot 1, 0, and 0 over 1, 0, 0 times 1, 0, 0 dot 1, 0, and 0. So it's going to be negative 1 over 1 times 1, 0, and 0. That's going to be negative 1, 0, and 0. That's the vector projection for the x-axis. If you want to find out the scalar projection, that's going to be negative 1. For y, it's going to be negative 1, 2, and 4 dot 0, 1, and 0 divided by 0, 1, 0 dot 0, 1, 0 times 0, 1, 0. So it's going to be 2 over 1 dot 0, 1, 0. It's going to be 0, 2, 0. And if you want to find out the scalar projection, it's going to be negative 1, 2, and 4 that's 0, 1, 0 divided by 1, which is going to be 2 over 1, and that's going to be 2. And if you want to do it on the z axis, just write the final answer. We can guess what is going to be the final answer. The final answer is going to be 4. It's going to be 0, 0, and 4. And the magnitude is going to be 4 as well.